Everyone, this is Om, the lead for the new robotics lesson, and I'll be teaching lesson 3, parts of the robot for sensors. Here would be our schedule in a normal class. And in today's lesson, we're going to be learning about sensors and starting our mini project. Learning about sensors. What is a sensor? A sensor is a device on a robot that measures something in or around the robot, such as distance, light, temperature, or touch. It turns it into data and sends that data to the robot's brain so the robot can react or make decisions. Here are some examples of some commonly used sensors. First, we have distance. Robots use distance sensors to detect nearby objects and avoid collisions. They emit signals like sound or light, measure the bounce back of time, and calculate distances for safe navigation and precise tasks. We also have the touch or bump sensor. Robots use touch or bump sensors as simple mechanical switches to detect physical contact with obstacles. They trigger on impact to stop or reverse for basic, low cost obstacle avoidance. Color sensors. Robots use color sensors, which are optical devices with LEDs and photodiodes, to detect object colors by shining light and analyzing reflected wavelengths. This can be used for color sorting items, identifying location, and more. Camera sensors. Robots use color sensors, which are optical devices with LEDs and photodiodes, to detect object colors by shining light and analyzing reflected wavelengths. This is very similar to the color sensor, by the way. So, this can also be used for color sorting items, identifying location, and more. As you can see, the camera sensor and color sensor have a very similar structure, so they can be used interchangeably. Analog versus digital sensors. There are some differences between the types of sensors that robots use. Analog sensors turn something in the real world, like light, temperature, or distance, into a smoothly changing electrical signal, usually a voltage that can take any value in a range, not just on or off. This means small changes in the thing become being measured cause small changes in the signal, so you can tell how much, not just yes or no. Now, on the other hand, we have digital sensors. A digital sensor turns something in the real world, like light, temperature, or distance, into a stepped electrical signal, usually just 0 or 1, which is translated to on or off. Not a smooth range of values, which means it can detect changes in fixed steps or thresholds. So you can tell yes or no, but not exactly how much. And we have a class discussion. Think of some sensors used in a robot vacuum. Discuss with your classmates on some sensors a Roomba may utilize and what it was for. An example of this can include distance sensor used for car parking assistance. You can pause the video here and think of this on your own. Okay, let's watch a quick video of a Roomba in action. And while we watch this, think about the mix of sensors it uses in real time. Here are some sensors used in Roombas that you could have seen in the video we just watched. For distance, robot vacuums use ultrasonic sensors as super ears. They emit sound waves that bounce off obstacles, timing the echo to compute distance. This detects walls and objects ahead of time for crash-free navigation, mapping, and suction adjustments in any light. Touch sensors. Robot vacuums use bump sensors as simple touch detectors or mechanical switches on the front and sides that trigger instantly when hitting walls or furniture. This provides immediate feedback for the robot to back up, turn, or retry a new path. For cameras, robot vacuums use camera sensors as eyes. A top-facing camera scans room landmarks like corners or patterns to build and follow detailed maps. This enables precise navigation, room targeting, obstacle avoidance, and efficient path planning. Another one is acoustic sensor. Robot vacuums use acoustic sensors as debris listeners and feel electric discs inside vibrate like drum heads when dirt or pet hair hits them during suction, detecting extra mess by impact sounds. This triggers intense cleaning, extra passes, and max suction on dirty spots until clean, saving time elsewhere. Now, let's move on to our second part of our lesson, the sensor mini project. Follow the instructions on the next slide to set up your playground and workspace. Some things to do before you start is set your playground to the wall maze located at the bottom of the playground menu. It should look like this in your VexCode VR. Once you do that, your workplace should look like this. After this step, you can start adding code blocks and beginning your program. Remember, we are trying to get the robot to point A in the maze. Try and think of the shortest path to get there and how you can do it using the front distance sensor, movement, and logic blocks. You can pause here and take your time on that. Okay, now moving on. Here's our class activity, which you guys just did. And here's the answer. Here's an example of a script that will allow the bot to reach a point A in the maze. If you didn't understand how this works, the explanation is on the next slide, which we will get right to. Understanding the code. This block, wait until front distance in millimeters is less than 50, tells the robot to drive forward until the front sensor is 50 millimeters away from the wall. Then, this block tells the robot to turn left for 90 degrees and continue driving until the front sensor is 50 millimeters away from the wall again. This block does the same thing before it sees the final wall after reaching checkpoint A, which then stops driving and parks itself right on checkpoint A. You can pause and take a look at this code and try to understand how it works. Moving on, we have office hours on Tuesdays and Sundays at 4:15 p.m. to 5:15 p.m. And here's the link to join the office hours. If you guys have any questions during the lesson or you weren't able to attend one class, please, we recommend you join office hours to catch up and in general learn what was taught in the lesson. Thank you, and I hope you enjoyed this video and it gave you some insight on the parts of a robot, specifically sensors. Thank you.